In this lesson, we will be talking about how to use the quadratic formula to solve a variety of quadratics. In fact, we can use the quadratic formula to solve any quadratic. So here's the quadratic formula. It's one of the more famous mathematical formulas. It's defined as to let a, b, and c be real numbers such that a is not equal to 0, and the solutions of a quadratic equation ax squared plus bx plus c equals 0 are x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Now, it's one of the lengthier formulas out there, and remembering it, sometimes it helps to have a mnemonic. I don't really have a mnemonic, but I have a little tune, which I will grudgingly sing, and it may help you. So let's try it. So it goes to Pop Goes the Wheels. Pop Goes the Weasel. Can't believe I'm doing this. All right. It goes. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. And I'm not doing it again. So anyway, that's the formula. And if you sing it to Pop Goes the Weasel, it will help you remember it. Anything put to music helps your brain retain. That rhymed. Okay, so the quadratic formula applied to, let's say, this sort of quadratic. I want to solve x squared minus 5x equals 7. Well, just like any of the other methods, except for square root, is you're going to want to set this equal to 0. So I'm going to go ahead and subtract 7 from either side, which will leave me with x squared minus 5x minus 7 equals 0. And now we are going to substitute our values into the quadratic formula, remembering that, in fact, a equals 1, b equals negative 5, and c is equal to negative 7. So x equals, remember, we're trying to solve for x. What does x equal? And it's negative b, so negative, and in parentheses, negative 5. So parentheses are our friends, so use them when you're substituting in numbers. Plus or minus the square root of negative 5 squared minus 4ac all over 2a, or 2 times 1 in this case. Now we just start solving this. I would recommend that you don't try solving this all at once. It's so easy to make a simple sign error, and then that'll throw everything else off. So, take the time, take a couple steps at least when simplifying this. So negative 5 minus negative 5 becomes positive 5 plus or minus, and this is going to become 25 plus 28 all over 2. And then x equals 5 plus or minus, and that's going to give us 53. So the square root of 53 divided by 2. Okay, so I would see if I could simplify this radical, but 53 I believe is a prime number, so we can't really do anything with that. So we have two answers. 5 plus the square root of 53 divided by 2, and 5 minus the square root of 53 divided by 2. And this is how I want the answers presented, as an exact expression as opposed to a rounded decimal. This provides for more better use when we get into applications of the quadratic formulas. And but let's look at what the graphical representation of this is. So if I were to, let's say, figure out the approximation of 6.14, so one value here is 6.14, so we'll jot that down. 4. And x is also approximately equal to, let's see, now if we change that to a minus sign instead of a plus, that gives us negative 1.14. So negative 1.14. Okay, now I wrote those down so that we can see what this looks like and get a graphical representation of our equation. So originally our equation was x squared minus 5x, x squared minus 5x, and I believe it was, yeah, minus 7. Minus 7. And I'll graph this. And I want to find the x-intercepts. Now there are 4 names that you need to be familiar with when finding, what x is equal to in a quadratic. It's called the solutions, that's one. Also called the roots. On a graph, it's called the zeros or the x-intercepts. All 4 of those mean the same thing. All right, so let's see, these would be the x-intercepts. So if we did this right, these will match up with our answer for the most part. So if you recall, if you don't remember, you might want to write this down. So if I want to find that, I'm going to go under second trace. This is my calc menu. And I'm looking for a 0. So the calculator calls it 0. So that's one of our 4 names. And I'm going to start with the one on the left. So I'm going to go to the left of that intersection. I'm going to press enter. A little arrow pops up there. And then I'm going to set my right boundary for which it's going to look. And I go to the right of it, and my other arrow pops up. So it's going to look between these 2 boundaries for where it's 0, where y is equal to 0. And it gives me negative 1.14, which is one of our approximate answers, which I put over here. Now, if I do the other one, second calc, and 0, I'll set my left bound on that one. Probably go a little bit further. All right, that works. And then I'll go to the right of it, press enter, and then press enter again, and 6.14, which is approximately what we got. So there are 2 solutions here, 2 real solutions. So that provides one of the possibilities for, one of the possible sets of answers we could get is 2 solutions. But let's look at alternatives or other possibilities. So let's solve another one using the quadratic formula. So we'll set this one equal to 0, 2. I'll have 16x squared. I'll have to subtract 17 from both sides here. So that's going to be minus 40x, and then plus 25 equals 0. And so my A in this case is 16, my B is negative 40, and my C is 25. So I have some larger numbers I need to work with. So x equals negative b plus or minus the square root of b squared minus 4ab C all over 2a. So 2 times 16. Now we'll start simplifying this. So positive 40 plus or minus 1600. Well, it works out. That's going to give us negative 1600. Okay, that's interesting. And then over 32. All right, so this works out to be 0. So we're just going to have 40 plus or minus 0 over 32. And the 0 doesn't do anything, so there's no point in having it there. So really what we have is 40 over 32. This reduces to 5/4. And so we only have a single answer. So what would that look like graphically? So let's put this into our graph, our calculator, and see what we get. So we have 16x squared minus 40x plus 25. I'll have my graph here. Okay, can't see that very well. I'm going to go ahead and zoom in on that. So option 2, and I'll move my cursor closer to the vertex and press enter. Okay, you can see that a little bit better. Okay, so let's see what it looks like. Just the vertex is touching or intersecting with the x-intercept, and if I calculate, that's my left bound, here's my right bound, guess, and that's about 1.25, and 5/4 is equal to 1.25. So yeah, that's messed up. So 5/4 is equal to 1.25, which means that indeed we only have one 0 here, and it is the vertex. So there's only one possible solution for x that will work for our quadratic. So that's a second possibility. So we can have two solutions. We could have one solution. Could we have more or less? Well, let's explore that possibility. Let's do one more. Okay, so in this example, it's already set equal to 0 for us. So all we have to do is substitute our values into the quadratic formula. So a is equal to 1, b is equal to -6, c is equal to 10. So here we go. X is equal to -b plus or minus the square root of -b squared minus 4ac all over 2a. So 2a. All right. 6 plus or minus the square root of 36 minus 40 over 2. So x equals, and I'm seeing that I have a negative in our radical, in our square root, over 2. Well, when I simplify this, I'm going to simplify the negative 4, so I have to evaluate the imaginary number. In this case, I'm going to have 6 plus or minus I square root of 4 divided by 2. And the square root of 4 is 2, so that's going to be 6 plus or minus 2i. We put the I behind the 2, divided by 2. X equals, and then 2 goes into 6 3 times, and 2 goes into 2 1 time, so plus or minus I. So we have two solutions that are imaginary, 3 plus I and 3 minus I. Well, if we graph this one, we have x squared minus 6x plus 10, and I graph this one. Let me go back to my standard window, which is option 6, and we see that it does not cross or touch the x-intercept at all. So there are no real solutions here. But we don't say, at this point, we don't say no solution anymore. We say, well, there are in fact two imaginary solutions, but we can't see them on a real coordinate plane. So the question is, what would that look like on an imaginary plane? Something to look at. Anyway, that is using quadratic formula to solve quadratics, and it works with everything. It's a pretty useful formula. So how do we derive the quadratic formula?